Good afternoon. How is everybody doing? We're still waiting for some more people to join us, but you know what? We're going to get started because this is a hefty topic. How many of you care about disaster recovery? I should hope. Otherwise, you're in the wrong session. So my name is Petter Sveum. I am the solution lead for our information availability products. For those of you who remember the name Veritas, we've resurrected it from its death. Good news? Yeah? I like it. Original Veritas employee way back when. So obviously the information availability portfolio, that includes all of our storage as well as our high availability and disaster recovery resiliency product sets. This is a new offering from us. So I want to talk about how we built it and why we built it and a little bit about what it actually does. Try not to be too product focused, but there you go. So, classic roadmap disclaimer. I'll provide you some guidance on where we are in the development cycle and what we have available today, but just giving you the guidance of making sure that you make decisions based on what's available. So, how many of you were part of Doug's session downstairs? So, a couple? All right, not too many. Oh, a couple more. So, here's the big, more or less the big challenge. We're going to talk about the challenge, we're going to talk about the architecture, and then we'll cover up in the back a little bit about the offering. So Doug kind of specified the requirement of the North Star for recovery as a service. What do we really need? Well, we'd like to recover anywhere. We'd like to have that capability. On-premise, private cloud, managed service, managed cloud, public cloud, traditional enterprise virtualization, even physical architecture across local sites and sites which are really far away. We want to do this for any workload. So in other words, an individual VM, an individual application, a group of VMs or applications, a multi-tiered service, as most businesses rely on multi-tiered services. Web front end, some form of middleware, and then database backend. We want to be able to do this for transactional databases as well as cloud scale applications. We need to meet the business requirements. In other words, how quickly do you really need to recover? And how much data can you afford to lose? We also want to do it in a way that's easy. Simplicity is key. If this thing is hard to do, it takes a lot of effort from you, you're not going to use it. You're not going to use it. You're going to say, it's easier to do it manually, and I can rely on my people. Lastly, we need to have a heterogeneous approach to this, providing you with the capability of leveraging the different types of vendors that you want in your environment. Holistically, though, what we want to do is improve automation, end to end. Automation reduces overall risk because you take all those manual steps, and when you're in a situation where you have to recover, that's when you really screw up, making something that's already bad even worse. But automation also saves a lot of time. It helps us reduce that time that we need to recover, and we achieve those recovery time objectives that the business requires. Lastly, it helps us save a lot of money because now you can automate. And I'll talk a little bit more about that. In particularly, we want to embrace hybrid cloud. Now, OpenStack's been around for a long time already. But we're just now starting to see organizations, large enterprise organizations, adopt it in their data centers. It's had its challenges with regard to resiliency. But still, even those who do, they still have traditional enterprise virtualization, VMware, Hyper-V, even KVM or Rev. So holistically, what do we need? We need global visibility. We need recovery automation. We need the capability to understand our readiness. In other words, what's our risk? Which things have gone wrong lately? We need to understand those. We need alerts to tell us that this isn't going to work. We also need to understand how quickly will I be able to recover. That means rehearsals or fire drills as they've also been known in the industry. We'll talk about that. If we're going to achieve more than an individual VM or individual application, we need orchestration. We need the capability of understanding what do we need to do first, second, what can we do in parallel, what do we need to do in sequence. What are the dependencies? And then we need some way of measuring against the business, because they're the ones who are going to pay for this. And then lastly, one of the key reasons why people set up DR in the first place is to achieve compliance with audit requirements, whether they're internal from a board level or actual public institutions that require some level of resiliency. This challenge is compounded by the fact that our environment, it really is heterogeneous. Everybody's using VMware. Many are also using Hyper-V. Some are starting to use KVM or Rev, and some are starting to adopt OpenStack. Everybody's using Windows, everybody's using Linux, but in multiple flavors. We have to cover all of those aspects. We also have to cover all the applications that run on these various hypervisors and VMs, operating systems. We need to have some understanding of that concept of an individual app, how it relates to other applications and services, and how they relate to site. Lastly, and this is probably the biggest challenge, data movers. How does data get moved from one site to another? Is it based on hardware array replication? That's the general theme in the industry for the last 20 years, 25 years. But the adoption of virtualization has introduced a lot of other types of data movers. I would say they came in earlier as well, so they've been around for a long time. But is your data movement happening in the application? Is it a log shipping that's managed by the database engine? Is it happening at the volume layer? Is it happening within the hypervisor software? So you're shipping the VM. Or is it a software-defined architecture where you've stretched out your entire software architecture, leveraging hyper-converged architectures to support your environment? Or using a storage appliance and replicating from one storage appliance to another? One of the key challenges, if you're going to have a hybrid cloud environment supporting multiple heterogeneous environments with running multiple different operating systems, how can you do that effectively leveraging any of these data mover technologies? I'll let you think about that. So this orchestration piece is the starting point. We need to understand the physical and virtual tiers. We need to have the capability to start and stop. That is going to lead us to the capability of building out our workflow. Whatever that workflow is. It can be small to begin with. As we add more components to our workflow, it becomes much more complex. We still have to make sure that it's simple and easy. So drag and drop is key. And then those have to be able to provide us with visibility of the health of this service. And we also have to be able to both perform our recovery, whether that's for migration, failover, or rehearsal. Lastly, we need to achieve scale. It's no good if we can only handle tens or 100 VMs. Thousands of VMs, maybe tens of thousands of VMs. And we need to embed these in resiliency plans so you can actually execute, I want to move from a site. All right, let's talk about architecture. So this is our starting point. We're providing our disaster recovery controller and allowing it to talk directly to the hypervisors and talk directly to the hardware array controllers. We're also providing a methodology which allows us to speak directly to the physical infrastructure so we can actually communicate and understand applications that are still in physical, Windows and Linux in particular. Then on our DR site, we have the same similar architecture. You can say no OpenStack's been introduced yet. We're still dependent upon array-based replication or hypervised-based replication. To achieve this, we need this DR controller, or DR as a service controller, to have a multiple different set of components. And this has been built based on a whole series of open source technologies where we've contributed into these technologies and allowed them to come to our use, if you will. Cheating a little bit. But holistically, what we need is a workload repository, something that can contain our workflows and our orchestration pieces. In essence, that is a Cassandra database. So non-SQL, stretched forever database. Initially, we're supporting only 2 controllers, but we can extend that. But in order to achieve scale, we need to have some methodology to communicate with our infrastructure, whatever the infrastructure is. So we need some infrastructure management servers that are going to communicate with our on-premise Hyper-V servers, our on-premise ESX infrastructure, our managed hosts, which are running some form of application, our arrays, etc. These are the samples of the types of interfaces that we support currently, but it's extendable, and we will extend it. Just giving you the same sort of view, but from a different perspective. How we're going to stand up the support to support various types of applications, VMs, hypervisor environments, and arrays. We don't really care where the application or the data movement is occurring at this point. At this point, it's all about orchestration and the capability of communicating directly with the interface that's going to manage the stop and start of a VM, the stop and start of an application, and the direction of replication. So, as we add in this infrastructure manager, we're getting our infrastructure manager component speaking directly to our resiliency manager component, leveraging open APIs or proprietary APIs from vendors or our host-based agents. Now, how do we extend this to a cloud? Right? Kind of giving it a bit of a crescendo here. You could possibly leverage hypervisor-based replication if the hypervisor is the exact same hypervisor. But in an OpenStack environment, yeah, you got some choice. Most customers, though, are looking to see, can I use KVM? Can I avoid paying the vendor tax for Hyper-V or ESX? That means that the replication has to come into our disaster recovery architecture. And we have to be able to cover that holistically. So we're going to introduce another component. That is the replication gateway. So within our replication gateway, we're going to have to have an understanding of what are the data sources that are being written and how can we capture them. We do that by deploying an agent holistically from our infrastructure manager into the operating system instances, whether they're physical or virtual. That agent has an IO tap, which understands it's basically a filter driver that's written holistically, works on Linux and Windows, allows us to discover all the IOs and passes that down to the replication gateway, which will then pass it on to our OpenStack environment. I'm going to introduce another topic here, or another concept here, which is key to the adoption of disaster recovery as a service, particularly for those who think about managed service, or those who are service providers and think about, I'd like to offer this to my customers. And that is the capability of just-in-time recovery. So with OpenStack, we have the capability of leveraging a sender-based storage component, doesn't matter what kind of storage it is, but connecting that directly to our replication gateway and storing our data there as we are replicating. Only at the time of execution, in other words, as we migrate, or as we do a takeover, or as we do a rehearsal, do we actually start up compute. So there is no allocated compute to this solution other than the resiliency manager, the infrastructure manager, and the replication gateway. Holistically, this means we need to ensure that we have a couple of added things. So within the replication gateway, we've built what we call I/O receivers. So the I/O tabs, which reside in multiple different hosts, connect directly to our replication engine via an I/O receiver. That, of course, has a journal attached to it. It connects to the replication engine, manages the transceiver, which also has a journal attached to it, goes across the WAN to the transceiver in the OpenStack environment, and where there is another replication engine that leverages an applier that sends the data directly to the Cinder storage. No allocated compute at this stage, other than the infrastructure components. This is going to be asynchronous. So obviously, we're not looking at synchronous replication here, right? If you wanted synchronous replication, that's not a problem. We can handle that in the host layer. But not every application needs synchronous replication, not for DR. So it's important to understand your recovery time and your recovery point objective. It is completely storage independent, both in terms of the storage that's applied here in your physical and virtual environment on premise, as well as what's built in your OpenStack environment. And it holistically ensures right order fidelity for all of the VMs or applications that are being replicated. You need to scale this, though, right? One replication gateway is probably not going to be able to handle thousands of VMs. That's correct. There are limits. There are limits to how many targets you can attach to a gateway in OpenStack. Anybody know how many? 16. That's it. There are limits to how many targets you can attach in a VMware environment. Anybody know how many? 24. These are odd, right? You find these to be the case. This to be the case in other public cloud platforms as well. These will change over time, but within the current time frame, we have to live within the limitations of storage configurations. So the point is that what we'll do is we'll scale out, leveraging multiple gateways, which will add in more transceivers, more I/O receivers, and more appliers. So what does this actually look like? What does it actually look from an actionable perspective? What can we do here? So first of all, and I apologize, there's no animation in this slide. Hopefully you'll forgive me. First of all, let's talk about rehearsal. So at the time of rehearsal, you execute, we're going to allocate compute. We're going to attach the Cinder snapshot directly to that VM, and we'll spin up the VM. We may start the application, depending on the configuration that you've set up, and then we'll let you do whatever you want. The rehearsal is basically built for testing whether you can achieve your recovery time objective, your recovery point objective. It's also really good for things like burst scalability. So I'm running a VM here, but I've run out of capacity in my internal site. I want to leverage a cloud vendor to burst into their cloud because they have seemingly unlimited capacity. I can do that. I can do that with rehearsal. I can do that with migration as well. In other words, migrate the entire VM. At this point, in addition to allocating compute, we're going to switch replication. And now we're introducing the idea of we're going to have an I/O tab here as well with a sender. It's going to go to a receiver here through the replication engine back to an applier. And now we're going to have an applier here back to my LUNs here. How does that work? Well, we got Cinder and OpenStack, so that's easy to use. But what do we do in VMware? In VMware, we're actually leveraging a proxy host that allows us to attach the devices that we're going to update through iSCSI. Easy. So we're just mounting those through that proxy and then writing continuously directly. So again, we're not dependent upon having a live host here. In the case of Hyper-V, it works a little bit differently, but it's very, very similar. Again, that's because of the subtle differences between these two hypervisors. Physical, we're still working on. So physical infrastructure, obviously, you're going to have an attached device. That's going to have an update. We can write through the agent, and we can do that in other products, but we haven't built that capability into this product yet. So there'll probably be an applier writing back to the managed host agent directly. Then lastly, what about an actual disaster? In other words, things have actually failed. My site is down, I need to bring things up. Well, in that case, you're going to just allocate your compute. You're going to attach your Cinder target, start your VM, maybe start your application. But at the same time, you're going to prepare for replication back. So that whenever this site comes back up, you're going to be able to initiate that replication immediately. Obviously, that's going to be a full sync. It has to be. Because you don't know what the state of the site was when it failed. We're working on trying to do something really smart to figure out exactly what the delta could be, so it doesn't have to be a full sync at the time of a takeover. So what does this actually look like? Well, it's fairly simple, easy. This is the UI where you see your site configuration, the number of VMs that are attached to a resiliency group. You can immediately run your migrate, takeover, rehearsal, as well as your cleanup of rehearsal in case you've actually performed that rehearsal. We leverage the failover capabilities, both migrate and rehearsal, to estimate the recovery time. And of course, we understand the replication lag very well. We give you the capability of executing these actions very simply. They are truly initiate, go, and once we build them out, drag and drop. You see how these consist of multiple steps. For each step, we log all of the actions that are taken. And by the way, we're not actually performing any complex tasks here. We're performing tasks that you would normally do one by one for individual VMs. But when you talk about scale, it becomes really complex. And it becomes cumbersome to manage holistically. So other aspects that I haven't talked about, updating DNS entries. In other words, removing DNS from one site and adding them to another, changing subnets. All of those things are built into the platform. So you basically just set policies. And we update Neutron. We update the networks for the VMs in OpenStack. Lastly, you can do this holistically for multi-tiered applications. So we understand the nature of one application's dependency on another. Again, it's a very much a drag and drop functionality to build that out. You take the resiliency group, you add it to a tier. You take another resiliency group, you add that to a tier. You can group these applications and VMs however you like. And then lastly, we give you a console that provides you with a holistic view of your environment, an understanding of where your applications and services are running, on what type of infrastructure they're currently running, and where they're being consumed. This console will add in other things such as risk, such as the understanding of how to improve your resiliency posture. That, in essence, is where we are today. In the future, we're going to add in recovery as a service, risk assessment, more in-depth workload orchestration, ensuring that you can holistically protect your entire environment. So this OpenStack solution that we talked about, we built together with HP Enterprise Services, and it'll be a part of our joint solution, which will go to market in January timeframe, which is called the HP Helion Veritas Continuity Service. That's an end-to-end, fully managed service. But all of that good stuff that we built together, both the replication gateway, the capability of integrating with OpenStack, KVM, et cetera, is going to be available for you or the general market in July timeframe, and in a do-it-yourself form factor. Now, at this stage, you can actually build a disaster recovery solution that allows you to fail over from any cloud or any private cloud to any private cloud, regardless of whether they're both built on OpenStack, they're both built on, or one is built on OpenStack, the other one's built on Hyper-V, one is built on multiple different hypervisors, etc. True flexibility and true global scale. And that's how we're going to achieve this. And deliver on the promise of embracing the hybrid cloud environment. I feel like I talked a lot. You guys were really quiet. So I'm going to open it up for some Q&A.
Are there any traditional Veritas products in this architecture?
In this architecture, we've more or less started from scratch. Okay? So there are a couple. For instance, the managed host agent. It's the same managed host agent that we have embedded in all of our storage foundation and VCS configuration. But it doesn't actually provide anything other than communication, and that communication is certificate-based, so it's easy to configure, set up. Doesn't require you to have any sort of added maintenance of passwords or users, etc. A couple of other things. So our understanding of the application, that comes from our high availability agents, so our VCS and application HA agents. But we're not actually leveraging the agent infrastructure to do anything other than stop and start, and then lightweight monitoring. The next question ought to be, will you integrate? And yes, we will. So I talked about the fact that, maybe I captured it, sorry. We talked about the fact that we want to be resilient, holistic, right? We don't want to interfere with the existing architecture. So if you're running a Microsoft failover cluster in your environment, whether it's in a physical environment or even in a Hyper-V or a VMware environment, at the guest layer, will still work. We'll understand that we're not going to break it. And in the future, we're actually going to leverage it. So let that cluster, whatever cluster technology we're talking about, provide us with detailed information. So query that directly and use that to actually execute our operations. Yep. Yeah. Good question. So for on-premise, yes. We'll extend to Unix already in February, January timeframe, supporting. That support will come through InfoScale, so through our cluster file system, cluster server, etc. So you'll have to have our solutions running on your boxes for us to support that. But that'll be there for at least Solaris, Spark, and AIX. We might also extend it to HPUX in the coming time frame. Now, how does that work? Well, so there are going to be some limitations in terms of utilizing the replication aspect of on the gateway, obviously, because the gateway is built specifically to cover x86 workloads. Doesn't work on Unix yet. It's not going to work on Unix for, I don't know, I don't even want to promise it, but that's where we are. But the whole point is you can orchestrate regardless of which type of replication you're using, and you can have multiple data movers in your environment. Yep. Yeah, so the initial support is for Oracle and SQL, but we have the understanding of the agent infrastructure from VCS and application HA for Sybase and Formix, etc. So we delivered the initial release of this product in July. We'll extend the agent infrastructure continuously. We release an agent pack every quarter to extend that footprint. So yeah, look at our sort website, Systems Operations Readiness Toolkit from Veritas. But anyway, come and ask me later about your favorite database. Which is your favorite, by the way? Okay. So we leverage a filter driver that sits in the operating system, right? So it's actually bit-based. All right? We capture every bit. Any other questions? Yeah, that is a really good question. At scale, we haven't tested it yet, at scale yet. We delivered our replication technology to HP in August. The work to QA that together with them is ongoing. So I don't have any numbers, but I would expect it to be minimal because we're actually not doing much locally. We're just filtering out that one I and writing it somewhere else. There's going to be some, obviously. There's going to be some. Go ahead. Yeah. 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 No, there is. Yeah, absolutely. So I want to talk about one thing. So in the replication gateway, we actually have the capability to prioritize different IO queues. So we can say, this one requires a higher recovery time, and we want to be near zero. And I mean, if your environment supports zero, no problem, right? Well, no, yeah. So look, in the case of zero, we would suggest cluster file system, right, with mirrored storage between sites, and you can do that on clouds, but that depends on something else. Yeah, and that's going to sit on top. But absolutely, the point is that we can leverage, we can set policy in the I/O taps to say that one has to have a higher priority than this one. So we can say you want to have 5 minutes, you want to have 10, or you try to have 5 minutes, try to have 10 minutes, try to have 15 minutes, etc. That, of course, is going to again depend on your infrastructure. So your next question would probably be, how much bandwidth do I need? So there's no maximum distance, right? That's the coolest thing. The test use case that you saw is between Pune, India, and Santa Clara in the United States. Yeah, exactly. So how much bandwidth do I need? And the answer to that question is really how much I/O workload do you have, right? That's the answer. So what we do is we run an analysis in advance to allow you to try and figure out how much bandwidth do you need. But because it's flexible and it's asynchronous, we can drop below our target and allow you then to buy more bandwidth to compensate. I guess last question? She's opened the door.
How do you ensure that you don't lose data if you lose complete source site?
Right. So you lose data if you lose the complete source site. That is guaranteed, right? So whatever hasn't been transceived or passed over to your target is gone. That is your recovery point objective. And the reality is we're not targeting a recovery point objective of 0. And if you think about other replication technologies, such as our own volume replicator that leverages a bunker replication. Now, there is the possibility in the architecture to do that. In other words, you have a third site where you have a bunker, and you can be synchronous between your source and your bunker. And then at the time of failover, you spool off the bunker before you start up the workload. That way you can achieve 0 data loss. But in essence, within this architecture as it stands today, there will be data loss if you lose your site. All right. Final question? All right. Yeah, you can have it. It's actually on the left out there. But no, I'll give it to the staff. They'll make sure you can get it. All right. Thank you very much. I appreciate your time.